which expects to be the leader of other nations, can expect to stay behind in this race for space.
Attention all operators on countdown 1. We're going to start our go-no-go poll for today's flights. Raptor 1, go. Raptor 2, go. Stage 1, go.
Good morning. On your screen is Starship as it awaits our first ever integrated flight test from Starbase, Texas.
Flight directors, go for flight. 10, 9, 8, 7, 6, ignition, 2,
Welcome and greetings from the 74th International Astronautical Congress here in Baku, Azerbaijan. I'm Clay Morey, president of the IAF, the world's largest international space organization with over 500 members from 77 countries around the world. It's my privilege today to host this live stream chat with Elon Musk, who's chairman, CEO, founder, and chief technology officer at SpaceX. Elon is also the winner of this year's prestigious IAF World Space Award that recognizes his exceptional impact on the progress of world space activities through his outstanding contributions in space technology and space management. Welcome, Elon.
Thank you. Thanks for having me.
Elon, I don't know if you can see, we have a huge packed auditorium here in Baku with a huge also live audience. We're streaming this on X and on the IAF web app, so thank you for joining us today. Let's talk rockets.
Absolutely.
All right. Let's talk really big rockets. Okay, let me take you guys back in time a little bit. 15 years ago, I think it was a week past, SpaceX successfully, on its fourth attempt, launched the Falcon 1 to space, to orbit. And I think it carried, if I'm correct, 165 kilogram payload. Today, oh, go ahead.
It was just a test payload on the fourth launch, so no actual satellite, because the first three launches unfortunately had failed. So we didn't want to risk the fourth launch with an actual satellite. But we're very happy to have launched a Malaysian satellite on the fifth launch of Falcon 1. Yeah.
Fantastic. So let me make the contrast. Today, you're preparing for the second launch of Starship, which has the ability to launch up to 150 metric tons in a reusable configuration. If I'm doing the math, and you're better than this at me, 900 times the capability, roughly, of Falcon 1? Am I getting?
Yes. Falcon 1 looks like a child's toy by comparison.
It's a staggering achievement, what you've done in 15 years, and all the team at SpaceX, I think we're all just in awe of how fast that progress has been made. and to pioneer reusability for orbital launch systems is, I think, something to be tremendously proud of, both for you and the team there. It stands, this vehicle now, I think something like almost 400 feet tall, roughly over 120 meters. It's a massive Starship spacecraft and super heavy rocket itself, collectively known as Starship. And it produces more thrust than the SLS system, the Saturn V, and Russia's old N-1 rocket. Is that correct?
Yes, the current version of the Starship produces just over twice the thrust of Saturn V, and with the upgrades we have in the works, it'll do about 3 times the thrust. So Saturn V in the sort of old Imperial system would have been 7.5 million pounds of thrust. We're at about 16 right now, and we with future engine upgrades, we'll take that to about 20 million pounds of thrust.
Amazing.
Yeah.
Simply amazing. So I know you guys have said you learned a lot from the April 17th from this first launch attempt. There's been some upgrades to the vehicle. I think it's a Booster 9 now that you're launching with Ship 25. Is that correct? Geeking out on the numbers. Yeah, the kids that follow online.
These numbers are maybe a little it's not quite the 25th booster, because what would happen is we would redesign we'd make a new design, and then we'd actually scrap units that were in progress. So it's 25 is perhaps, it sounds like we built 25 units, but we haven't actually built 25 units. We built probably about 12. Still a lot. Yeah, so but the way to think of it really is that this is Flight 2, and has a number of upgrades on both the ship side and the booster side. We've done a lot more with engine isolation, which is incredibly important. We've tried to draw as many lessons as possible from the Soviet N-1 rocket, which is probably the closest in design to Starship. I believe it had 29 NK-33 engines, if I recall correctly. That was quite a high thrust rocket. And unfortunately, I think actually that rocket, on all things considered, was a great design, but did not receive sufficient ground testing, so never made it to orbit. But that would have been the sort of the closest, probably parallel to Starship. Really the biggest difference, the most fundamental difference of Starship is that it is designed to be fully reusable, with both the booster and the ship, or both the first and second stage are designed to be fully and rapidly reusable. So that sort of for a truly profound revolution in mass to orbit, you have to have I call it the four R's: rapidly reusable, reliable rockets. RRR.
I love it.
Like a pirate.
R. Everybody give me an R. R. All right. So what does success look like for this flight number 2? What does success look like for you? What are you trying to achieve?
Well, I do want to set expectations, well, not too high. So there's a tremendous amount of new technology in this rocket. We have actually changed the entire stage separation system from something that was I'm not sure how to describe this, but kind of just a rotation and flip. We're trying to move to a passive stage step system where you don't have pushers, essentially, to try to eliminate parts. There's no pushers, no interstage like Falcon 9 has, and with Flight 2, we're actually trying to do hot staging. So hot staging would mean that we light the ship or upper stage engines while the boost engines are still partially thrusting. So we throttle down and shut down most of the booster engines. Then we light the ship engines, and there's a vent area which looks comically small, actually, which hopefully is enough, because you're essentially blasting the top of the booster with the ship. Now this is actually, from a physics standpoint, the most efficient way to do stage separation, and the Soviets and later the Russians made extensive use of hot staging. But of course, this is the first time we're doing it, so I'd say that's the riskiest part of the flight for Flight 2. And if the engine's light and the ship doesn't blow itself up during stage step, then I think we've got a decent chance of reaching orbit. Technically, it's a scooch below orbit because it's going to do almost a complete circle of the Earth, but then splash down somewhere in the Pacific, just off the coast of Hawaii, because the ship is designed to re-enter and has a heat shield. So we want to make, now we don't know if this, we think it'll work, but we aren't sure if it'll work. So if it doesn't work, we want it to not work over the Pacific, which is a very large body of water, with almost no people on it. So.
Excellent target. Excellent target.
Yeah, exactly. I mean, I always think it's funny that people call Earth because Earth is water. Earth is 70% water, and if you take an actual round version of the Earth, not a Mercator projection, but at the globe, and you center it on the Pacific, it just looks like water. It's like, where's the land? So anyway, this is quite helpful when you're doing experimental rocket flights.
So how many more test flights are coming up, and when do you think you're going to try to catch Starship on a tower?
With our giant Mechazilla?
Yes.
Giant Mechazilla. Listen, I saw Kong versus Godzilla, and that's what gave me the idea. In fact, if we gave our tower legs, it could just tromp around like Mechazilla. But we have a giant custom-designed tower with massive mechanical arms that will literally try to catch the booster and catch the ship. Which it sounds insane. I mean, I haven't even seen a sci-fi movie that does this, But in theory, it should work. Let's just say success is in the set of possible outcomes. I'm not sure what the probability is, but success is somewhere in that. Is success possible? Yes, I think it's possible. In terms of catching it, I think. For the ship side, we obviously want to make sure that it actually comes in fully intact and lands at a precise location in the Pacific before we try to catch it at the launch site, because we're taking every precaution we can so that we do not risk any human lives or destruction of property. So it'll be a few flights. So for the ship, it'll be when we see the ship landing at a precise position in the water, that's when we will try to catch the ship with our Mechazilla on the tower. The booster, obviously, booster flights we've done many times on Falcon 9, so we're much more familiar and have a much higher confidence with booster recovery. We've actually had the booster boost back to land and land at Cape Canaveral Air Force Base many times, albeit with landing legs, not with the Mechazilla arms. So booster, I think there's a decent chance, depending on when our licenses are granted, that we would catch the booster within the next year, or maybe less than a year, and then hopefully, if we get lucky, we might catch the ship towards the end of next year.
And where does the catch take place? Is it Willie Mays in the middle of the outfield over his shoulder, or is it Florida somewhere?
No, so both the booster and the ship come back to the launch site.
Okay, fantastic.
Yeah, that's what I mean by this. In fact, I mean the thing that since we need a giant tower with customized arms to lift the booster and the ship onto the launch pad, we don't absolutely need it. We can technically do it with humongous cranes on a low wind day. But that's quite unwieldy. The tower with the arms is capable of lifting the booster and the ship even on a very windy day, or moderately windy day. So then it just seemed to me that, well, if we can lift the ship and the booster, the ship onto the launch stand, or the booster onto the launch stand and the ship onto the booster with those same arms, we should be able to catch the booster and the ship with those same arms. We've gotten pretty good with the thruster-based landing, and in fact, we can make the rocket hover in midair. In fact, we were able to do that many years ago. If you look at the old Falcon 9 test videos, which we called Grasshopper, where we'd actually take the Falcon 9 booster and we'd have it just go up and hover at 100 meters and then translate over another 100 meters, then translate back and then come back and land. So we were able to do that really over a decade ago. It's not obviously very efficient with propellant to have a rocket hover, but it can be done. So that was, I was like, okay, well, let's just have the rocket come back and, hover briefly, and have then the arms come together and catch it. So that's the general idea. Is going back to what I was saying, it's not just reusability, it's rapid reusability, and it doesn't get more rapid than bringing it back to the launch site. And so, in principle, the booster comes back very fast, by the way. One way or another, that booster is coming back to land, or it's going to land fast, because with the high thrust to weight that we're aiming for, which is sort of on the order of 1.3 to 1.4, and a staging ratio which is currently about 3 to 1 in favor of the booster. So propellant the propellant on booster to propellant on ship is about 3 to 1 on the current version, but it's trending closer to 2 to 1 on with future versions. That means that we're shifting more and more of the delta V burden to the ship side. That means the booster actually uses up its propellant quite quickly, and we'll trend towards only about 100 seconds or so of booster flight. And the booster will immediately flip around, boost back to the launch site, and land. And so it really, we're talking about the booster being back at the launch site in about 4 or 5 minutes, which is pretty wild to think. It's like a 5-minute booster basically. It's landed somehow, whether it's either crashed or it's landed it's been caught by the arms, one of the two, and within 5 minutes. And so then it lands back on the launch stand, and you can then refill propellant. The booster, the ship side obviously is going to take a minimum of an hour and a half to get around the planet. Still going pretty fast, but you got to circle the globe. And obviously that depends on what inclination, and so what's your launch azimuth, what's your inclination of the booster as to whether it has a flight coming back over the launch site or not. If it's technically possible to do it in a single orbit, depending upon your launch inclination.
Very good.
So booster come back in an hour and a half. The ship could come back in about an hour and a half.
Any prediction on when you're going to start deploying satellites with Starship?
Yeah, I think we will start deploying. I think there's a good chance we start deploying Starlink V3 satellites next year, in roughly a year from now. Because we before we are confident that the ship, like I said, the hardest part about this, or the part that will take the longest, is solving for safe ship reentry and landing. But before we solve that, we can launch the satellites, because in any case with Falcon 9, the upper stage is expendable. So it's actually fine to start launching satellites even before we solve for ship reusability. That is the hardest part of the equation. So with Falcon 9, we've gotten pretty far with reusability. The booster, it's now highly unusual for the booster to not come back and land. It's gotten quite normal for the booster to come back and land. We now have a couple of boosters that are I've done 17, I think 18 flights at this point. And the fairing is also recovered, so the fairing reusability is also solid. But the Falcon 9 design does not allow for reusability of the upper stage. And the Falcon 9 while reasonably rapid, especially if you've got a return to launch site landing, still takes at least a few days to refurbish before you can fly it again. And so with Starship, actually more profound than the size is the fact that it is designed to be fully and rapidly reusable. The reason for the absurd size is that we're trying to build something that is capable of creating a permanent base on the moon and a city on Mars. That's why it is so large. Otherwise, we could make it much smaller.
So I think the diameter of Starship inside the envelope is something like 9 meters, and inside the top envelope is about 17 and a half meters of usable volume. This is an incredible amount of space, right? Unheard of volume. What does that open up the possibilities? What kind of things can we fit in that space? What does it mean for the industry as we look ahead? Maybe you can give me how many whales or how many Starlinks can you stuff in there? I don't know what the right metric is, but give us a sense of size.
Well, I mean, like when you step into the Starship fairing or payload volume, it looks like a cathedral. It looks absurd, frankly. It's like, wow, this is ridiculously gigantic. That was my first impression when I first went up there in a man lift and climbed through the little hole for the Starship initial rough prototype. I was like, what have we done? This thing is ridiculously big. So now this actually can be great for science, though. One of the exciting projects that we're working with is with the Sol Perlmutter at Berkeley on a telescope, a space telescope, that is able to use it's got an enormous lens. I think it's perhaps a 7 or 8 meter diameter lens, and it's actually a satellite that was meant for the lens was meant for a ground-based satellite. But if you then take that same satellite and put it in orbit, its capabilities are greatly enhanced because you don't have the obfuscation of the atmosphere. So that's why, for example, the Hubble, which is actually a fairly small telescope, can do better than I think maybe any historical ground satellite, especially in the visual spectrum. So we're very excited about what it can do for space science. Because really at this point, especially for any photons where there's interference with the atmosphere, so any sort of short wavelength photons, you really want your satellite to be in vacuum, or rather your telescope to be in vacuum.
Yeah.
So that's really the future. So I think there's a lot of exciting potential there for planetary for space science. But like I said, really fundamentally the reason it's so gigantic is that if you're on a long journey to Mars, I think being cooped up in something the size of a minivan would be unappealing to most people.
Just so comparison for the audience here, I think the Hubble telescope was something like 2.4 meter diameter, and so you're talking about I think 3 times the size, somewhere along that order for the Mir. That's incredible. We've seen some changes down there in Texas at Starbase. I don't know if that's where you're streaming from here today, but there's a new factory that you're working on to enable a faster manufacturing rate. Can you talk to us a little bit about that? What are your goals? What are you trying to achieve with the new factory?
Yeah, so we are building a giant factory for a giant rocket, I mean, honestly, I recommend people visit Starbase. As it turns out, it's on a state highway. So I think it's one of the rare situations where, and I actually don't mind. I think it's kind of cool that the public can actually drive within a literal stone's throw away from the factory and the launch site and actually see the rocket firsthand. And in fact, if you go on the internet right now, including on the X platform, there are people who are live streaming it 24/7, the entire construction, launch pad, everything. So it's people say like, well, can I go see it? It's so easy to go see. You can just literally fly to Brownsville and drive to the beach, and you can see it literally a stone's throw away, the factory and the launch site. So anyone who wants to do that, I recommend it. It's very, very easy. No permission required. So yeah, we're building this giant rocket factory. The engines are still manufactured in California at SpaceX headquarters in Los Angeles, which is also it's also an odd location. That's where we built the Falcon 9 rockets and the Dragon spacecraft. Really, about 5 minutes from LAX, at sort of what used to be a Northrop headquarters, I believe. But yeah, we're building this giant factory. So the thing is, so in order to, if you look at in the grand scheme of things, say, okay, what is required to have a self-sustaining base on Mars or city on Mars? You have to really think of it in terms of very large tonnage. And if we can even get the tonnage estimate to correct to within an order of magnitude, I think we'll be doing well. I think we should probably aim for something like 1 million tons of useful load delivered to the surface of Mars, which requires roughly 5 million tons to Earth orbit. So, because you get about 20, for whatever mass you get to Earth orbit, you get about 20% of that mass landed to the surface of Mars. Give or take, maybe you can get 25% optimistically. So that's why this thing is so gigantic, is we've got to get 5 million tons to Earth to orbit, which hopefully gets about 1 million tons to the surface of Mars, and hopefully 1 million tons is enough to create a self-sustaining city on Mars.
Incredible. So talking about Mars, any new predictions on when I know this is your ultimate goal, your destination, any predictions on when Starship might land on Mars without crew, maybe a crewed flight? Any prediction there?
Well, I think 3 or 4 years.
4 years. That would
be something like.
All right.
I have to check with the Earth Mars. Earth and Mars. Have orbital synchronization about every 26 months. So you can't just you fly to Mars when it's on the other side of the sun from Earth. That's unwieldy. So roughly every 26 months, the orbits are in the right relative position, and then you have the Mars transport window. So I think I think it's sort of feasible within the next 4 years to do an uncrewed test landing there. Yeah.
Didn't have enough on your plate. You're doing a lunar lander version, yes?
Yeah. Well, really, Starship should be a generalized transport system to anywhere in the solar system. That's the intent. With when you have propulsive landing, you can land anywhere, whether there's an atmosphere, no atmosphere. It's not really dependent on water. Obviously, for crewed capsules on Earth, we've generally gone with parachutes and water. And in Russia it's on land, but then they need retro rockets right at the end to sort of slow things down. So a propulsive system should generalize to be able to land anywhere on a solid surface, anywhere on in the solar system. So the moon, while it's sort of dusty, the moon is actually harder than it's not just a big dust pile. So it's harder than you'd think. The lunar regolith. So I'm sort of optimistic that we can take a Starship that's fairly unmodified from what would land on Earth or Mars. Obviously, you need legs, but apart from that, I suspect you could land the Starship with minor modifications on the moon, and the same would go for once you have a propellant plant on Mars. You could then go to the asteroid belt and the moons of Jupiter. If you can establish a propellant plant there, then you could go to the moons of Saturn and ultimately all the way out into the Kuiper belt and Oort cloud.
What you're talking about requires propellant transfer, obviously, in orbit. Can you explain to everyone watching why that's necessary and how it works and how you work to progress to make that propellant transfer happen?
Yes, so really propellant transfer is a similar problem to just docking. Now, we've gotten pretty good at docking with the Dragon going to the space station. And docking with the space station is really quite difficult because we didn't design the space station, and the space station has a lot of complexities and has crew on board. So we have to be extremely careful, and so docking with the space station is like, I would say, it's far more difficult to dock with the space station than it would be to dock with our own spaceship. And so propellant transfer just really means that we send a Starship up there with no payload, and it just transfers its propellant to a ship that is already there. So you have to dock with the ship that is going to Mars or the Moon, and transfer the propellant from a version of the ship that has no cargo. Now there'll be a future sort of tanker optimized version of Starship, where we, we stretch the tanks and have little to no cargo space, because that's the optimal thing for a tanker. But you don't have to do that. That'll increase the propellant load of the tanker, or the propellant transferability of the tanker. But it's not absolutely necessary. You could in theory use an unmodified Starship and transfer propellant that way. So
I would imagine that you're doing this, and you may have multiple launches in either rapid succession or maybe multiple pads launching multiple versions of the vehicle. Does that all take place from Texas, and how quickly do those launches have to take place to make this work?
Yeah, we'll have a launch site in Texas as well as in Florida. So we've actually partially built a Starship launch pad at Pad 39A, which is where we launched Falcon Heavy and our crewed Dragon. So we've partially built, and we'll fully build that out over time, and probably have at some point a greenfield location for Starship at the Cape. Now, in the sort of, you say like 4 or 5 year time frame, where perhaps we're launching several times a day, then we may need to go to an ocean-based platform. Just if you're launching, I don't know, 10 times a day, that might be a bit much even for the Cape. I don't know. So we may end up doing platform-based launches from a specially designed sort of ocean-going platform. But we will need to do a lot of launches. I mean, we're talking about thousands of launches per year. So so you do get up to the sort of what I was talking about, million tons or 5 million tons to orbit. That if you've got 1,000 launches a year, each of which do over 100 tons, that's 100,000 tons of a cargo, per year to orbit. That's still not quite enough. I think we'd want to get to roughly 1 million tons of orbit per year, to Earth orbit per year, which would mean that you get to 1 million tons to Mars in 5 years. Now, these are very big numbers, obviously. Just put things into perspective. All of Earth launch capability right now, apart from Falcon, is about 400 tons to orbit per year. Falcon 9 this year will do, I think, around 1,500 or 1,600 tons. So Falcon 9, it's already doing about 80% of Earth mass to orbit. And next year, we expect to increase that by about 40 or 50% on the Falcon side. So, maybe 2,500 tons to orbit for Falcon next year. But these are still small numbers compared to what's required for essentially making life multiplanetary. For making life multiplanetary, you've got to be in the sort of hundreds of thousands to millions of tons to Earth orbit per year.
Unbelievable numbers, really. As somebody who worked in the launch business for several years, it's incredible for me to even try to think about that much mass to orbit in 1 year.
That's crazy.
Yeah, it's absolutely crazy. Ludicrous mode, I think. Yeah, for launch.
Very much so.
Yeah.
But it's either we do that or we're a single planet species forever. So we either achieve those kind of numbers or we will never have a self-sustaining city on Mars.
To building this amazing launch system, you're also working on a Polaris mission that's going to allow, I think, Dragon to open and have people actually floating in space, doing an EVA, and you're building a spacesuit for that. So you can talk to a little bit about that spacesuit, and can you use that same suit on the Moon and Mars and for other missions?
Yeah, so the SpaceX spacesuit, we do expect to evolve that to be something that can be an EVA suit on the ground on the Moon and Mars. It started off initially as really just a pressure suit, just in case there's an emergency depressurization of the spacecraft. So it was basically like a self-contained life support system in suit form. Obviously we'll retain that capability, but now for an upcoming flight, we want to do an EVA or extra vehicle, basically go float around in space. Still on a tether, so it's not going to be an independent little space suit that's just flying around. We could do that, and maybe that'll happen on a future flight. But it will be a tethered EVA. You're just out there floating in the void, connected by a thin cord to the spaceship.
Amazing. You put a Tesla in space. This was like an amazing thing to see, a Tesla actually flying into space. So you've already put one of the vehicles in space. Are you thinking about making a Tesla rover, maybe Moon or Mars? Any ideas for a Cybertruck on the Moon?
It would look cool, that's for sure. The nice thing about electric cars is that obviously do not require oxygen to. They're not combustion cars, so they don't have to ingest oxygen from the ambient atmosphere. Yeah, I think Tesla could easily make a car that like a Cybertruck lunar variant. Just get the Moon option package. Yeah, I mean the reason that we launched the car. The reason we launched the car with heavy, I should say, is it's just that we want to have something that was exciting as a initial payload, but where the loss of the payload would not be catastrophic. So people wonder why is my car orbiting Earth and Mars? Because it's in an elliptical orbit. And actually, it almost touches like the edge of the asteroid belt and goes past the orbit of Mars. It's just that we weren't sure if the first flight of Heavy would fail or not. And we wanted to just have a payload that was more exciting than a Falcon.
I thought it was brilliant, really a masterstroke in terms of getting attention of the world, really, to put that in orbit.
Thanks.
Can Starship be used as a space station? How long could it stay in orbit, and what would be the purpose of that? How could that work?
So how long could Starship be in orbit?
Yeah, could it be its own space station? If you wanted to put a Starship up with a capability, a laboratory, how long could that could it stay in orbit and still come down?
Oh, there's no real limit. It could stay in orbit for a very long time. The volume of the Starship fairing is roughly comparable to the volume of the International Space Station. So there's about 1,000 cubic meters of volume in the fairing. And I think space station's a comparable amount. Yeah.
And would have the power to run a lot of laboratory experiments? Sorry.
Yeah. Given that it's a similar volume to the space station, you could do what you're doing in the space station on a Starship if you want. But there's no limit to how long it can stay up there. It's really just you need solar panels, battery, and some thrusters to maintain orbit.
How about point-to-point transportation? I know when you were in Guadalajara at the IAC, you kind of hinted at a little bit of the point-to-point capability of transportation. I can't remember the exact amount of time to get from one side of the world to the next, but can you talk about that? How do you see the future of point-to-point using Starship?
Yeah, so the fastest way with known physics to get from one place to another on Earth is with an intercontinental ballistic missile. This is why ICBMs with nukes are kind of like the ultimate weapon. Now in this case, it's sort of delete the nuke at landing, but it's certainly very feasible. Obviously, if we can take off and land on Mars or the Moon, we can take off and land on Earth too. So it really comes down to a question of is it economically viable compared to long-distance aircraft? And I think our back-of-the-envelope numbers suggest that it actually has a shot at being economically viable for long-distance transport on Earth for a few reasons. The propellant cost is actually quite low, being liquid methane, liquid oxygen. The cost of liquid oxygen is primarily liquid oxygen. It's about 78% liquid oxygen by mass, and roughly 22 or 23% liquid methane. So the propellant cost is it's the lowest cost propellant you could possibly get on Earth, and then because the rocket's moving so fast, you can use it in theory about 10 times more than you could use an aircraft. So so Falcon 9, Starship can go from, let's say, Los Angeles to Sydney or something like that in 20 minutes, basically, maybe half an hour at most. So, whereas I think an airliner takes about 14 or 15 hours. So you've got something which is really much faster than an aircraft, and so for an airliner that you can do basically an order of magnitude more trips with Starship than you can with an airliner, which means that no pilots are needed. In fact, you can't pilot. This is not only a computer can pilot this because human reaction times are not fast enough. So then you don't have the pilot costs, you don't have the food costs, you don't have the you don't really even need bathrooms if you can get there in half an hour. So it actually would work out that it's actually, we think, lower cost than long-distance aircraft.
Okay, you got a little chuckle here in the crowd about the no bathroom line, so I think people are looking forward to it.
Yeah, I mean, it's less than half an hour, you say like, just go before you hop on, and yeah, you'll be there fast. I mean, you could technically, have, I don't know, breakfast in LA, lunch in London, and, dinner in Singapore, and then be back in LA for bedtime.
All right, you heard it here, guys. Huge round of applause here.
Yeah.
So you're connecting now, I think, something like 2 million people with Starlink, right? With your satellite communication system and growing rapidly. You're mastering communications from space to Earth, from low Earth orbit. You're now doing inter-satellite links with this system. What do you see for Starlink being used as a relay, let's say around the moon, or for comm relay all the way to Mars and back?
Yeah. Well, for Mars, you'd want basically like a laser relay system. Essentially, it sort of depends on what bandwidth you're looking for. Obviously, in order to have continuous coverage with Mars, you'd have to have some relay system because you can't transmit through the sun. So when Mars is on, when the sun's between you and Mars, you have to do a bank shot through a relay satellite so that your photons don't have to go through the sun. So and then you have to say, well, ultimately we want, terabit, maybe petabit level data transfer between Earth and Mars. So then you're gonna want probably some relay satellites along the way to be able to do that. It's a bandwidth thing. You'd want to use lasers, and then the laser beam is going to widen with distance, so that then you need to be able to receive the laser beam before it gets too wide. This means that you need a series of satellites in order to communicate with Mars at its furthest distance, especially with very high bandwidth. You can obviously do low bandwidth with longer wavelength photons, but if there's a human city on Mars, you'd want to have very high bandwidth. So then for a bunch of lasers. And satellite, Starlink already uses lasers for inter-satellite communication.
So if I may, just a couple more questions. Throughout this week here at the IAC, we've been inspired. There's thousands of young people here. I think 41% of our delegates are under the age of 35, which is incredible by any space conference metric. We get a lot of young people here. There's delegates from the Space Generation Advisory Council, from the Future Space Leaders Foundation, from the YP program here at the IAF. Do you have a message for these young people, the young engineers and scientists that are here? Many of them have been inspired by you. Anything you can say to them about pursuing a career in space, or what motivated you to do all the things that you're doing?
Yeah, I'm interested in that which furthers civilization, and I think we want to expand the scope and scale of consciousness so as to better understand the nature of the universe, and even to understand which questions to ask. Like, one of the most inspiring books I ever read was The Hitchhiker's Guide to the Galaxy, where they're trying to understand the meaning of life in the Hitchhiker's Guide, and the larger message of the Hitchhiker's Guide to the Galaxy is that you actually need to know what questions to ask about the answer that is the universe, and we don't yet know what questions to ask. So I'm just curious, really. I'm just curious as to the nature of reality. Where does it all go to? Where does it come from? Where are the aliens, for example? Are there aliens? Or are we alone? People often ask me if I'm seeing any evidence of aliens, and I unfortunately have seen no evidence of aliens yet. We are the aliens, as far as I can tell. And I think if anyone would know, it would probably be me, and I have not seen any evidence of aliens. So what that perhaps suggests is that this tiny candle of consciousness that is humanity is all that exists in a vast darkness. And we should do everything we can to ensure that the candle does not go out.
Bound. We've had a wonderful week here in Baku. Yes. So we've had a wonderful week here in Baku. Next year we're going to Milan in Italy for the 75th IAC. We would love to have you come back for sure. If you're in the neighborhood, or you can hop over in a Starship, we would love to have you.
Sure. It would be quite the entry. It's going to land on the roof.
I'll ask the Italian host to see if that's possible. So just a fun question at the end. When do you think we can host an IAC in outer space?
That's a good question. Probably less than 10 years.
Let's have it. Well, Elon, I'd like to thank you for joining us today. Congratulations on the World Space Award, well deserved, and our pleasure. We'd love to have you back. Good luck with your next launch.
Thank you. Thanks. It was an honor to be interviewed. Thank you, everyone.